In this question, we're going to look at this problem here. So you write this down for me. So, given a wire of length, now Matt, how long did you say it was? 30 centimeters. Here's what the question asks you to do. Find the dimensions which give the maximum area. Find the dimensions which give the maximum area. Okay? So is that question clear? So we've been given a length of wire here, and we want to find out the maximum dimensions, find the dimensions gives the maximum area to create this rectangle. Yeah? Is that clear? Yeah? Yes, good, awesome. How do we go about doing this? Well, in your worksheet from last lesson that I gave you, it asks you to do some perimeter calculations, but then it asks you to start doing this algebraically. Because the thing algebraically is that we don't really know what the dimensions are going to be. Okay, we don't know what the dimensions are going to be. So here are the steps that I'm going to tell you in order to solve these optimization problems. And hopefully this applies in a pretty general sense. So first step, if you can, always draw a diagram. Right? A diagram is going to give you a visual sense of what's going on here. So draw a diagram. Now often, like when you've been thinking about your functions, right? Your functions that you've been differentiating, what have they been looking like? Well, they've been looking like this, like y equals to x squared plus 5x plus 6. That's an expression that you would get, you would differentiate it, you could find the maximum or minimum, classify stationary points. So we need to somehow introduce these variables. And we need two variables, right? We need to introduce two variables, and we can generally call them x and y. Sometimes they'll change the letters based on like what the situation is. So if it's like P for profits, N for number of things you're producing. But either way, we need two variables, okay? Now sometimes they'll actually give you the equations, Harry, that you need to use. Yeah. But if that's not the case, then you need to find or kind of create the equations. So create equations if not provided. So sometimes they'll give it to you, sometimes they won't. Like sometimes they'll say show that this is the equation that we need, but sometimes you may have to make them yourself, right? And last but not least, like this is the most important part that we were talking about. Hey, what's this whole calculus topic about? It's about finding maximum and minimums based on using calculus. So we want to find the max or min. And Eva, when you find maximum or minimums, what's the important thing you have to do after you find the values? Test. Classify. Right? So can you see how this skill here, right, step 4 is essentially what you've been doing before. But we have 3 other steps now that we need to introduce. Right? And these are probably the more difficult steps because hopefully you have enough practice with these kind of skills that you can just do them if you're given the function. What if we're not given the function? Okay, so let's go ahead with this y situation. So here's our rectangle. Okay, I want a visual sense of what's going on. So let's draw a picture. So this is step 1. How do you like my rectangle? Okay. I can do better. I can do better. Half mark? Do I get half marks at least? All right, step 1. Draw a picture. James, does this look better?
Other side, no, there's no parallel.
How do you like it?
It's slightly better, but like the top and bottom lines are.
8 out of 10? 8 out of 10?
Maybe.
6. I mean, that's a pass. I'll take it. Okay. Here's step 1. Draw a diagram.
Horrible marks there. 6.
Step 2. We want to introduce some variables. So how can we introduce variables? There's no variables at the moment. What is the area formula of a rectangle? Yeah, but like there's so many different ways of writing it, like length times breadth based on, we usually write length times breadth or length times width or something like that, right? I'm going to keep it as x and y only because like when we get to the differentiating part for step 4, you're more used to seeing them as y and x, right? So that's probably more familiar for you. So I'm going to let x and y be the width and length. So step 2, we need to introduce some variables. Let x and y be the width and length. And we're going to put this on our diagram. Yeah? So x is our width, y is our length. Now, step 3. And this is the part where sometimes people just kind of see it and then sometimes they just don't, right? So I'm looking at this question and I'm like, okay, there's still no equations here though. I need to somehow create some equations which relate to this situation. Because I want to, at the end of the day, differentiate something, okay? So how can I introduce some how do I create some equations? Bless you, Lauren. Okay, when you want to, I'll give you a tip. When you want to create an equation, okay, think about what you're dealing. This is why I've given you the diagram, yeah? What do you know about this shape? That is not right.
It's a rectangle, sir.
It's a rectangle. What do you know about rectangles?
I have to find the perimeter.
How do you find the perimeter, Harry?
Y plus Y
Yeah?
plus X.
So the perimeter,
And then the area, Y times X.
yeah? And the perimeter and the,
Area.
and what's the area?
Times X.
Okay, so,
Am I doing it right?
yeah, that's good, it's good. Now here, we can do a bit better, okay? Because, yeah, 2y plus 2x. But remember, we want to create an equation. Right now, this here is an equation. You've got something, the area is equal to x times y, yeah? We've also got the perimeter, but the perimeter right now is not an equation, it's just an expression. Like all you've done is write 2y plus 2x, yeah? How long is the perimeter?
30 seconds.
Oh, well done, Harry. You're exceeding expectations at the moment. So let's write this out. Here's our first equation. Area is equal to x times y. So it's kind of confusing when I write 1 in here again. So equation 1, area is x times y. And the equation 2, what did you say my next equation was, Harry?
2y plus 2x.
Yeah.
30.
What is the perimeter? 30. Okay, so far so good. So here are our equations. The area is equal to x times y, and I'm going to leave that as a, so I can actually work with that mathematically. And I've got that 2x plus 2y is 30. Can you see how year 12 you just created your equations? Yeah. All right. So not too bad. Yeah. You just have to think about the situation you're dealing with, and you have to think about what formulas do I know that are involved here. They won't spell it out for you. They didn't tell you anything about that in this question. That's why step 3 is often very difficult. Okay. Once you've done that, I still need something that looks like this. Right now I've just got like this a here, I've got these 2x plus 2y is 30. So I've got these two equations. What am I doing with them? This is where you go back to the original question. What did we actually want to do? What's the question asking for us? Find the biggest area given some dimensions. So I want to find x and y that give me the largest value for a. And when you think about differentiating this, you're using calculus on this, right? When you are differentiating, when you're finding the maximum, you're finding the maximum or minimum value for y, right? When you're differentiating that expression. Does that make sense? Yeah. So which expression do I want to look at differentiating here? What am I trying to maximize? What do I want to maximize here? Harry just said it.
Area.
The area. Which equation has area here? The first one. This is the one that you want to look at. Okay, so once you create these equations, this is the one you want to focus on. Why do I? Yeah, Joel, go. There you go. No, what do you want to say? Yeah. What is the next step? Good stuff, mate. Yeah, you're already ahead of me. So, Joel's realized, hang on, I can't really differentiate this right now because there's two variables here. In order to differentiate, right, you've got the two equations, but in order to differentiate, you need one variable when you're working with calculus, at least in this course, yeah? Okay, so let's go with what Joel said. Let's rearrange this one. So which one do you want the subject as? Yeah, let's make, we can make y the subject. So let's, actually, before we rearrange, we could divide both sides by 2. Would you agree? So from equation 2, All right, we can say, all right, well, I'll divide both sides by 2. So x plus y equals to 15. And then y is equal to 15 minus x. Are you happy with that, Joel? Yeah? Okay. And what do you want to do with that? Yeah, so this is still kind of like a part of step 3 here. We want to substitute y is equal to 15 minus x into equation 1 with the goal of saying, okay, I'm just going to have a single variable here. So a is going to be equal to now x outside of 15 minus x. So a very important part of step 3, when we create the equations and we want to get to step 4, maybe make a note, it's probably going to involve a simultaneous equation. At some point, you're going to have 2 equations, and you're going to have to somehow relate them together. Yeah? Because right now, these are separate. This is talking about area. This is talking about perimeter. They're not related at all. Okay, how do we relate them together? That's what I'm looking at.